In the fiscal year 2026 defense budget, buried inside hundreds of pages of procurement line items, is a $50 million entry for something called the External Heavy Stores Pylon Program. That is government language for reopening hardpoints on a 40-year-old bomber that everyone assumed was headed for the boneyard and loading it with weapons that travel at 5 times the speed of sound. Before we dive in, comment where you are watching from and click subscribe. 45 B-1B Lancers, up to 36 missiles each. If the math holds, that is over 1,600 standoff weapons deliverable from ranges that keep the aircraft entirely outside the threat envelope of any air defense system currently operational. China held emergency planning sessions when the upgrade was announced. Russia is watching a weapon system their Cold War defensive architecture was never designed to counter. And the Pentagon is describing it with characteristic understatement as a stopgap measure. It is not a stopgap. It is a structural shift in how American air power delivers mass fires in a high-threat environment, and it emerged not from a next-generation development program, but from engineers examining a retired bomber and asking a different question. To understand why this matters and why it matters now, you have to start with what the B-1B actually is, what it was designed to do, what it became, and what it is becoming. The requirement that produced the Lancer dates to 1955. The Air Force wanted a bomber combining the range and payload capacity of the B-52 with supersonic sprint capability for penetrating Soviet air defenses. The result flew for the first time in December 1974 as the B-1A. President Carter canceled the program in 1977, citing cost. President Reagan revived it in 1981 with a modified design. The B-1B traded maximum velocity, dropping from Mach 2.2 to Mach 1.25 for a dramatically reduced radar cross-section and significantly increased payload capacity. At 75,000 pounds of internal payload, the Lancer became the heaviest lifting bomber in the American inventory. Its variable sweep wings gave it a range of operational profiles: wings forward for maximum range and fuel efficiency, wings swept back for high-speed, low-altitude penetration runs beneath radar coverage. 100 aircraft rolled off the production line between 1985 and 1988. Each one was designed to carry 24 nuclear-tipped cruise missiles. They were built for a specific war against a specific adversary using a specific strike model. Then the Soviet Union collapsed. The New START Treaty removed the B-1B's nuclear mission entirely in the mid-1990s. Conventional bombing became its only purpose, and in that role the aircraft proved remarkably capable. It struck Iraqi targets in 1998. It flew continuous combat operations over Afghanistan for 2 decades, providing close air support to Special Operations Forces who valued having a Lancer overhead precisely because it could loiter for hours and deliver immediate precision fires on demand. It launched 19 missiles at Syrian chemical weapons infrastructure in 2018. As recently as last year, B-1Bs flew 34-hour non-stop missions from Dyess Air Force Base in Texas to strike targets in Iraq and Syria without a single intermediate landing. But sustained combat operations at that tempo extracted a cost. The hot, abrasive operating environments of Iraq and Afghanistan were punishing on airframes and engines. Maintenance ratios climbed to 48 hours of ground time for every flight hour in the air. By 2021, the Air Force made the decision to retire 17 of the least serviceable aircraft, preserving the remaining fleet until the B-21 Raider could arrive in sufficient numbers to replace it. That was the plan. Then engineers looked more carefully at what the remaining airframes could actually do. The B-1B had 6 external hardpoints that were physically sealed when the aircraft's nuclear mission was eliminated. They had been inactive for roughly 30 years. Modern materials and computational design tools suggested those hardpoints could be not just reactivated, but significantly improved. Boeing engineers developed what they designated load-adaptable modular pylons, mounting systems engineered to carry 7,500 pounds of payload each, exceeding the original hardpoint specifications. Computational fluid dynamics analysis verified that external stores in various configurations would not create dangerous airflow disruptions or push the aircraft's center of gravity outside safe operating limits. Software integration required updating the store's management system to recognize the new pylon stations, calculate external weapon release profiles, and program safety interlocks for the additional configurations. The primary purpose driving all of this work was hypersonic weapon integration. The AGM-183 air-launched rapid response weapon accelerates to speeds above Mach 5. Current testing indicates a B-1B configured with both internal bays and external pylons could carry up to 31 of these weapons simultaneously. No air defense system fielded anywhere in the world was designed around the problem of intercepting 31 hypersonic missiles launched in a coordinated salvo from a single aircraft operating hundreds of miles from defended airspace. The intercept geometry at Mach 5+ flight profiles does not allow the kind of engagement timeline that conventional air defense procedures require. The reaction window is too narrow, the incoming angles are too varied, the saturation density exceeds what current battle management software can prioritize and sequence fast enough to matter. The B-52 fleet, the obvious alternative test platform, was already fully committed to a parallel modernization program covering new engines, new radar, and new communication systems. The Air Force needed a dedicated airframe for hypersonic weapons development and integration. The B-1B provided that airframe, and the testing being conducted on the Lancer is generating operational data on employing hypersonic weapons from a high-speed, low-altitude platform, data that no other aircraft in the current inventory could produce. Hypersonics are not the only capability unlocked by the Pylon program. The long-range anti-ship missile addresses what the Air Force formally describes as an air-launched capability gap against high-threat maritime targets. The context behind that bureaucratic phrasing is direct. China has been constructing one of the largest naval expansion programs in modern history. Multiple aircraft carriers are operational, with additional hulls under construction. Chinese anti-ship ballistic missiles are designed to hold American carrier strike groups at risk throughout the Western Pacific. A B-1B loaded with 12 long-range anti-ship missiles on external pylons plus 24 additional missiles internally is a platform capable of threatening an entire carrier battle group from a single sortie. One aircraft, 36 weapons, a range of nearly 600 miles on each one. The strike capacity that represents exceeds what many nations possess across their entire tactical aviation fleet. The Joint Air-to-Surface Standoff Missile Extended Range receives the same multiplication effect. A B-1B currently carries 24 internally. Add 12 on external pylons and you have a single bomber capable of conducting a full suppression of enemy air defenses package without escort aircraft, without waiting for defensive networks to be degraded by other assets, and from well outside the engagement range of the systems it is targeting. The timing of this program is not coincidental. It is a direct response to what Pentagon planners call the bomber bathtub, the period during which older B-1Bs and B-2s are retiring faster than the B-21 Raider is coming off the production line. The Raider is not delayed in the conventional sense. The production ramp-up timeline is largely unavoidable. Northrop Grumman's industrial capacity cannot be doubled by congressional budget authority alone. Tooling, workforce, and supply chain development operate on their own schedules regardless of procurement funding levels. The gap between the aircraft retiring and the aircraft arriving is real, and it coincides with the period of highest geopolitical tension the United States has faced since the end of the Cold War. The operating cost arithmetic reinforces the case. A B-1B costs approximately $63,000 per flight hour. The B-52 runs roughly $72,000. The B-2 Spirit requires approximately $135,000 per flight hour. For the cost of a single B-2 sortie, you can fly 2 B-1B missions, and with the new pylons, those 2 B-1B sorties collectively deliver more total missile capacity than the B-2 strike they replaced. The B-21 will carry higher stealth performance and greater penetration capability against fully intact integrated air defense networks. But once air defenses are suppressed, the follow-on strike problem, destroying remaining targets, hitting distributed logistics, sustaining pressure across a target set is a mass fires problem rather than a stealth problem. The Lancer, reconfigured, is precisely the instrument that phase of a campaign requires. The criticism that the upgrade funding should instead accelerate B-21 procurement collapses against the basic industrial constraint. The money cannot buy aircraft that cannot yet be built at higher rate. It can, however, buy combat capability that is deliverable within the current fiscal cycle on airframes that are already in service. The global response to the program has been immediate and measurable. Chinese state media began publishing analytical pieces on the B-1B upgrades with particular focus on the hypersonic capability. The strategic concern is straightforward. If American bombers can launch Mach 5+ weapons from 1,000 miles out, the entire geometric assumption underlying Chinese integrated air defense architecture becomes unreliable. The standoff distance exceeds the range at which Chinese surface-to-air systems can engage the launch platform. The hypersonic flight profile reduces the intercept window to seconds. The combination of standoff launch and terminal speed creates an engagement problem that current Chinese defensive systems were not designed to solve. Russia faces an analytically similar problem with an additional historical dimension. Soviet air defense planning during the Cold War was built around the assumption of nuclear exchanges rather than sustained conventional bomber campaigns with precision standoff munitions. The prospect of a B-1B carrying 36 precision missiles against conventional targets represents a threat category their existing defensive architecture never modeled as a primary scenario. Their own hypersonic development programs address the offensive dimension of that competition. The defensive dimension remains a fundamental vulnerability. Iran provides the most recent real-world illustration of the operational concept the B-1B upgrade serves. Strikes against Iranian nuclear facilities demonstrated that penetrating defended airspace requires stealth platforms operating at low radar cross-section. But the follow-on problem, destroying hardened infrastructure, hitting dispersed targets, sustaining strike pressure after initial air defense suppression, requires mass and range rather than stealth alone. A B-1B loaded with hypersonic weapons and operating at standoff range represents exactly the combination of speed, payload density, and reach that a follow-on strike campaign demands. The current service life extension plan keeps 44 to 45 B-1Bs operational through at least 2032, with extension to 2036 under evaluation. Several aircraft previously retired to the Davis-Monthan Air Force Base storage facility in Arizona are being regenerated back into operational status. When a Lancer suffered maintenance-related fire damage at Dyess in 2022, the Air Force pulled one of the stored airframes back into service rather than accept a reduction in operational numbers. The fleet is being treated as a resource to be preserved and expanded, not managed toward retirement. External Heavy Stores pylon program funding runs across multiple fiscal years. Current appropriations cover wind tunnel testing and software development. Subsequent budgets fund pylon production and aircraft integration. Flight testing of the complete system, including live weapon releases, follows that. By the late 2020s, combat-coded B-1Bs are expected to be flying with full external load configurations as a standard operational posture rather than a test configuration. A bomber designed in the 1970s, built in the 1980s, stripped of its original mission in the 1990s, and sent to fight counterinsurgency campaigns through the 2000s is, in 2026, becoming the primary test and integration platform for the fastest air-launched weapons in the American arsenal. It is being transformed at a fraction of the cost of a new aircraft into a missile truck capable of delivering more standoff firepower per sortie than most nations can generate across an entire air campaign. The engineers who found those sealed hardpoints and asked what they could carry were not preserving a legacy platform. They were identifying a structural solution to a timing problem that no new development program could address on the required schedule. 45 aircraft, up to 36 missiles each. That arithmetic is now inside the planning models of every potential adversary who has reason to be concerned about American air power. The bone, as it turns out, still has considerable life left in it.